Telescoping gauges are an indirect measurement tool capable of picking up internal diameters and grooves through the use of these spring-loaded rods. Really quickly, the way that this works is, say you have a hollow section of tubing and you want to know its diameter, you insert the gauge at an angle, you tighten the spring-loaded mechanism, and you slowly start to move the gauge horizontally. Eventually, you'll reach the smallest length of those rods, which is going to be the diameter of the tube. We do a little bit of rocking back and forth just to find that smallest spot. We can then lean the gauge out. And the reason it's called an indirect measurement tool is that now we have an external feature that can be measured through a pair of external micrometers. Let's walk through that again, but this time with this pipe. It's the same internal diameter, but I cut away a section of it so that you can see how I'm maneuvering the gauge inside of the bore. The drawback of the telescoping gauge is that it is a little bit artsy, and you have to find that feel, that tight spot, in order to get an accurate measurement. I insert the gauge at an angle. Clearly, this is the longest the top of the gauge is going to be at during this process. Think of this as a hypotenuse of a right triangle. The hypotenuse is always longer than either of the two legs. But as I search for the center line, that bottom line of the triangle, the diameter of this tube, those rods become compressed. Now you can see here, I'm getting close to that horizontal line. At this point, I want to tighten the top of the gauge just gently. The threads are very fragile, and we still want those rods to be able to compress because we haven't found the center yet. But we don't want them to spring out once we go past that shortest distance. We just rock it a little bit, and then we come out the other way, the other angle. From here we can now measure this outside length. Now for this, we don't use the ratchet stop. We just look at the gauge and kind of move it around and see when it gets caught. If you put too much force on the spindle, you're going to compress the gauge, which is going to give you an undersized measurement. This is the most common mistake when using telescopic gauges. Again, I'm just going to wiggle around, making sure the gauge is perpendicular with the micrometer. That seems good. We'll lock this guy. Now this is a 1 to 2 inch micrometer. So whatever we get off of these readings, we have to add 1 inch to it. Looks like we have 850 thousandths of an inch on the main scale. We have 21, 22 just below that datum line, so 22 on the thimble, 22 plus 850, that gives us 872. There's going to be a little bit of change. We need to pick up those tenths, which looks to be around right there, and that's 6.8726 inches. But don't forget, we have to add that 1 inch. 1.8726 inches. Just to make sure it's clear, it's this screw at the bottom which locks the rods into place. So this is tight, loose, tight, loose. And please don't torque this down. This thread is very small and delicate. If you get the right tension, you can compress the rods and make them stay. This is the tension you want right as you're going through the diameter of your internal feature. Definitely play around with this screw and with the tension on the rods. before you start taking measurements. Unfortunately, these gauges are a little bit crunchy just because they're on the lower end, but high-end gauges are buttery smooth.